Hello, this tutorial will explain how to use the raised 3D prism machining toolpath options available in Aspire and VGov Pro to carve decorative raised lettering such as this letter S that we have here in our two-dimensional view. These are the sort of letters that typically carved very large and into very thick materials. You'll see that the edge of the cutter is used to form the shape on the letter. If we just delete this for a moment or switch the bitmap layer off and show us a schematic, this is a cross section through one of the letters, and the software calculates the toolpath to use a wide angled V-bit. Here we've got a 90-degree angle V-bit to form the edge on the lettering. So the software calculates toolpaths that will plunge into the material and form this edge at different depths. So the tool will move it down, forming the edge of the lettering at each pass. But one of the challenges here is that although it's relatively easy to calculate this smooth surface, there's a lot of material in this triangle area here that first needs to be removed to allow that edge to be formed by the cutter. The raised prism machining toolpath automatically takes care of this for you. Okay, let's just close this file for a moment. So file close. Not going to save the change. Let's create a new file. Let's say a piece of material that's 24 inches by 24 inches. And as I've said, to form these sorts of letters, you really need quite thick material. So we're going to use a piece of 3-inch thick material. Click OK. Now if you use the option to add some text inside the selected vector, or because there's no vector selected, it will be inside the material boundary. Let's say a letter S. We'll make it a Times New Roman font, make it bold, and apply. So there's our letter S scaled to fit in the two-dimensional view. Now if we swap from the drawing tab to the toolpath tab, let's just check our material setup again. So 3-inch thick material, retract height of 0.1 of an inch, click OK. Click to select the letter S and open the prism machining toolpath form. In here we select a cutter. So let's say we're going to cut this piece using quite a wide angle cutter. So we'll use an 1.25 inch diameter 90-degree included angle bit. So 1.25 inch 90-degree, and we can also specify a pass depth. Now the maximum pass depth, because it's 90 degrees, is going to be the radius of this cutter. So let's make it 0.6 of an inch. And this assumes that we're cutting relatively soft materials, and these letters will often be cut out of sign foam, which you can run the router into very quickly, and they're relatively easy and fast to cut. We've also got some options here for clearances. So clearance pass step over, let's make that quite large, so 0.5 inch, and a finishing pass step over, we'll make that say 20 thousandths. We also on this page would specify the step overs and the speeds and feeds for the cutter. And if we say apply, click OK to select that cutter. If we click the option here to set the depth here, it's telling us that when we're using this 90-degree V-bit, we need material thickness that is at least 2.6 inches thick. If the material is less than 2.6 inches thick, you'll end up with a flat spot on the top of the letter, because the angle of the cutter can't form the fully raised prismatic letter. So 2.6 1-inch thick material, we're okay here because we've got 3-inch thick material. Now if we just calculate this toolpath, the software's automatically created the toolpaths in the three-dimensional view for us. If we twiddle the view with the left mouse button, you'll see that we've got multiple pass depths. So 1/2 inch pass steps down, forming the letter. If we preview this toolpath, so if we say preview, the software's rough machined the top layer 1/2 inch deep. Now it's gone down another layer, so it's 1 inch deep. Then it will go down another layer, and it's forming the edge of the letter there. So you'll see there the smooth side face on the letter S has been formed with our 90-degree V-bit. The next thing to do is to profile machine around the outer edge of the letter to cut this out of the material. So to do that, we say close. Let's calculate a profile cutting toolpath. Let's say we're going to cut this out with something like a 1/4 inch end mill. and we're going to go all the way through our 3-inch thick material, machining around the outside, and calculate. And we've got lots of passes there, far too many passes, so double click to edit the pass depth. So let's say we've got a pass depth, we can cut 1/2 inch in one go, calculate. Oh, let's do that again. So profile, edit. Sorry, the pass depth here should have been 0.5 and we're using our 1/4 inch bit. So OK, and calculate. So we've got fewer passes. So now if we preview that toolpath, this will machine around and cut the letter out completely. So we can say delete the waste material, and that just leaves us with our raised prismatic letter there. So you'll see if we twiddle this up and view along, just view along the center of the letter S, this edge or this face is being formed with our 90-degree V-bit. So just to summarize again, we've drawn a letter in the 2-dimensional view, and we've used the raised prism machining to machine the material away. So we go to the 3D view, machine the material away from the edges, leaving us with this raised prism shape. These sorts of letters would typically be they'd be gilded with gold, and then they'd be assembled as, or stuck on and mounted as separate letters into a sign or a suitable design. Thank you for watching the tutorial.